So we're continuing with methods of partial fraction. This is part 4, and this is an example where the denominator is basically some linear form to a power. Again, we're starting with simple, and it gets a lot of, when you gain experience, you make it more algebraically complex problem. Is the simple here is just it means that it's algebraically simple. It's no new material is simple, just algebraically simple. And so in this case, the first step is already done again. So the first step is done, the degrees are matching. And then the second step is also done, because I see the denominator is x plus 1 to power 2. And that's the format that I want. It's all linear and to a power, basically. And then on the step 3 is the setup. So if you remember, what I need to do is I need to set up the integrand, which is 2x plus 5 over x plus 1 to power 2, and that's power 2, so I want to set it up into basically to the power 1, and then another one that is power 2. There we go. And so doing so, if it's linear in the denominator, the numerator still has to be just a constant, basically. And notice that I choose different constant for each fraction. And I start from A, B, C, D, and all the way, right? Now, how do I find A and B? So that would be part of this step, basically. And again, similar to what we did before, what I want to do is I want to basically, if I was given the right hand side, I would do a common denominator, and a common denominator here is x plus 1 to power 2. Not to power 3, but to power 2, right? Why? Because that one has factor x plus 1 to power 2, and that one has x plus 1 to power 1. So basically, this fraction goes unchanged at this point, plus b. And this fraction is multiplied by x plus 1 top and bottom. So bottom is already written down, and I write x plus 1 to power 1, basically. Now clean this up, and what I get is 2x plus 5 over x plus 1 to power 2 is equal to ax plus a plus b over x plus 1 to power 2. Now, again, this is where I'm going, right? I want this integrand to be equal to these partial fractions, but the partial fractions add up to this fraction, and these two have the same denominator. Therefore, I have to set the numerators of the two equal to each other, and that would be setting 2x plus 5 equal to ax plus a plus b. Again, look at the coefficient of x, and look at the constant. I'm doing 3 lines under the constant, and then on the coefficients of x, I'm doing, just circling it, right? So this basically, this equation is telling me, because x can be any value, this equation is telling me that 2 and a have to be equal to each other, and then 5 should be equal to a plus b equal to 5, right? And so this solves for a is equal to 2 and b is equal to 3. Right? So now, going back in here, that means that my integrand is going to look like this. 2 over x plus 1 plus 3 over x plus 1 to power 2. And so in this case, let's see, if the next step is to integrate. And so that integral is going to be equal to integral of 2 over x plus 1 dx plus integral 3 over x plus 1 dx. In both cases, you do a u substitution and u and u. And so this would be 2 natural log of x plus 1. That one is going to be, let's just do the u substitution really quickly. This one is 2 over u du. That one is 3 u to power negative 2 du. Because u equal to x plus 1, then du is going to be equal to dx basically. And so that gives me, for the first one, is 2 natural log of u plus, and this one is 3u to power negative 1, so it's a minus 3u to power negative 1 because divided by negative 1 plus c. And so the final answer becomes 2 natural log of absolute value of x plus 1 minus 3 over x plus 1 plus c. And so that's how we find the answer. So the next question is going to involve the quadratic forms, basically, the next 2 examples in the videos.